Hello everyone, this is Dr. Praveen Verma from ADARSH VIDYA MANDIR, Mount Abu. Students, today we will discuss about the electron affinity. That is a periodic property. Now first thing, what is electron affinity? The electron affinity may be defined as amount of energy which is released during addition of an electron in a neutral gaseous atom. So this amount of energy is called electron affinity, and as it is energy, so the unit will be what? Electron volt, joule or kilojoule. So when electron is added to a neutral gaseous atom, an anion is formed. So we can represent it as A. Suppose there is an atom, neutral atom. When electron is added, so A minus 1, A negative is formed. And during this process, as amount of energy is released, so what will happen? There will be decrease in the amount of energy of our system. So the sign of enthalpy or energy delta H will be what? Negative. So if we see the value of the first EA, it is what? First EA. The electron affinity, we can use what? For electron affinity we can use EA, that is electron affinity. So it is what? First EA. So if you see the first EA, the value of first EA is what? Negative. But suppose we have added one electron and we want to add one more electron, the second electron, and the amount of energy for the change in the amount of energy is called what? Second EA. So actually the addition of second electron is not easy. Why? Because the already present electron or the already added electron will repel this incoming or new electron. So it means in that second process we have to actually what? We have to provide the energy, and the energy of system will increase. So the sign of delta H will be what? It will be positive. So actually the second EA is what? Positive. The value of second EA is what? Positive. So always remember these two things. The first EA, it is negative. Delta H is what? Negative for first EA. And delta H for what? Second EA, you can say enthalpy change, that is what? Positive. Now next, the factors which affect the electron affinity. So there are mainly three factors. First one is atomic size or radius, you can say. Second, atomic number or Z effective. And third is stability of full-filled and half-filled orbitals. So now first point, atomic size. We all know as atomic size increases, so the attraction force between nucleus and outermost electron what? Decreases. So it means the attraction force towards what? Incoming or new electron will also decrease as atomic size increases. So we can say that electron affinity is what? Inversely proportional to atomic size or radius. As atomic size increases, the electron affinity decreases. Or we can say, suppose we see the change in a group. So you know, as we move from top to bottom in a group, so atomic size increases. So what will happen? The electron affinity value will decrease, or it will become what? Less negative. Less amount of energy is released, you can say. Now next, second point, atomic number. So as atomic number, you know, or it is also called Z effective, effective nuclear charge. So as atomic number increases, the atomic size decreases, we know this thing. And as atomic size decreases, the electrostatic force of attraction towards what? Outermost shell electron or incoming electron will increase. So the value of the electron affinity will also increase, or it will become what? More negative. Delta H will become what? More negative. So we can say that electron affinity is what? Directly proportional to atomic number. Now next point, stability of half-filled and full-filled orbital. You all know that the half-filled and full-filled orbitals are more stable. So as they are more stable, so it is not easy to add one more electron in that, because it will disturb their what? It will destroy their stability. So actually for such element in which there is half-filled or full-filled electron configuration, they are stable. So the electron affinity value is very low, or it may be what? 0. So this topic is finished. We will continue next topic in next video. Thank you.